Well, hey everyone, it's Bill Sickert, Director of Corporate Development for 7.2, and we are here in my home kitchen. And normally I am the guy that has the white coat on doing all the little tests, but today is a very, very special moment for all of us at 7.2 because I have the founder and the inventor, Dusan Miljkovic, for with us today.
Hi everybody.
So,
it's a pleasure to be with Bill at his place, his laboratory here.
Yes, absolutely. So, folks, what we're going to do today is a demonstration, and this is really what I call the whole enchilada demonstration because usually we have the ability to check pH with pH paper. You've all seen these little pH papers.
Or pH meter.
Or a pH meter, and Dusan has brought out all the toys today, so one of them costs about as much as a good car. So
this one,
the molecular hydrogen
molecular
test.
hydrogen,
and then
the probe.
Yeah, and we're also going to do the NORP test, and that stands for negative oxidative reductase potential. You've heard that many times out of my mouth. We're going to explain in detail exactly what all these tests are going to be doing. So, Dusan, if you want to, I will go in and introduce the product to the beakers.
Sure.
Can I have those honors?
Yeah.
Okay.
We have the product in the form of the powder.
Yes.
Which is
So
going to be the new one.
Very exciting that we're launching the powder now, and I am opening the bottle for about the second time here in my life, and it looks wonderful. And we are going to do a half dose, a regular dose, and then a dose and a half, and we're going to measure the differences between the two. And I think it's going to be exciting to see some of the differences.
3 times 200 ml of distilled water in these 3 beakers.
Right, distilled water is in these beakers. So here it goes, and real time here, and that's one dose. And Dusan, I have to tell you, I've never seen anything dissolve as nicely as this. Oop. There we go. And then 1,
3 little scoops.
yeah, there we go. 2 and 3. Very good. I can hear that.
Yeah,
Effervescent.
it's effervescent. The effervescence comes from CO2, from carbon dioxide, but not for molecular hydrogen, which is going to be dissolved in water, and you won't see molecular hydrogen. It's in nanobubble shape and size, and it's invisible. So if you see some bubbles, this is CO2, that's fine.
And look at how well that disperses without any stirring. That's almost perfect.
It's almost perfect.
Amazing.
And the other one. So we will probably wait a couple of minutes in these beakers that the reaction takes place to the end, to completion, and then we will start measuring certain
the real testing.
parameters. Yes.
All right, very good. Well, Dusan, since we have this going on right now, a lot of people in the audience have not met you at all. I've known you for years, so I can brag about you a little bit to start. But Dusan is an interesting individual. He has a very significant chemistry background and a pharmaceutical background. I actually met him when he was working in the pharmaceutical community, in the heart of the pharmaceutical community down in La Jolla, California. Torrey Pines area is biotech capital of the world.
Exactly.
When I first met him, I realized the genius that was within his mind, but the thing that I liked most about you was your heart and your heart for human health, and just the reality of you as a human being. So I'm just very happy to have you as a friend. But if you could share a little bit about your more of the linear background, more of the chemistry background.
Okay, sure. I with a lot of pleasure. I started my career a long time ago. I don't disclose my age at the moment because it's not. So
I'm not either, so that's okay.
It's not relevant. But anyhow, I started a long time ago as a student of chemistry, and then took PhD in chemistry, in organic chemistry, in Belgrade University, Europe, former Yugoslavia, and then spent 2 years in Switzerland with Nobel Prize winner in chemistry, doing the most complex synthesis you can imagine, and still the most complex synthesis stays nowadays, vitamin B12.
So the guy you were working with was a Nobel Prize winner.
That was Eidgenössische Technische Hochschule, ETH, a famous school, and Harvard. Professor Woodward, Nobel Prize winner, you can check this in Wikipedia, and I was really very friendly with late Professor Woodward, who was absolutely a genius guy. So you would ask, how come that from vitamin B12, the most complex organic molecule synthesis, I end up with a simple molecule like hydrogen?
You beat me to the question.
Yeah, that's a big question. The issue is that I discovered this 5 years ago and realized immediately that although it's a small molecule, it's such an important molecule, one of the most important antioxidants in the field, with a fantastic property to be dissolved in so-called nanobubbles, negatively charged, which are activated and which do a lot of health benefits. We'll talk about that more. And transformation came, as Bill pointed out. I wanted something which really helps massively to the people, to a lot of people. Because if you do some extreme, difficult solutions to science, and this is your frontier of the science with some very complex molecules, you're still far away of helping. You are helping mankind in a prospect in future, but not immediately. But working with hydrogen, you see that you can help people immediately because it works now. When I say so, let me put a couple of examples how it looks. If you suffer from a headache or from fibromyalgia or for some reason you feel really bad, this works if you take this hydrogen pill or hydrogen powder. It works within minutes, and this is what makes you to become fan of that, because you love if you see the results as soon as immediate. You don't like to see the results when it comes days and years after. That's one extreme. So you see an immediate result. If you are running like a sport guy or dunking in basketball, you will do better with this hydrogen.
I've experienced that personally.
The other thing, which is also not to underestimate, but you wouldn't believe, is that it has a strong anti-aging effect. Over years, taking hydrogen all the time and regularly, you keep your youth, your freshness. That's also very important, but you don't see this.
Just yet. So we, which is exciting for me, because we at 7.2 are truly the pioneers of the anti-aging aspect of this product, and we're just starting that race.
Exactly.
So that's.
So the other aspect of that is really anti-aging aspect, and the first aspect is really to get rid of some immediate problem, like a headache or some pain or arthritis, and for the moment you walk better or whatever. So that's in short what's up, and I would love to check with you together what we have here.
We can start our process.
So maybe
the one question that comes up with a lot of people is how long did this take? Because I'm looking on the label and the ingredients, and it seems somewhat simple, the ingredients. And what I explain to them is that, well, for instance, magnesium comes in over a dozen different forms, and the ratios of them. So, can you share just a little bit about that struggle?
Yeah, you know,
you make it sound easy, and it's not.
The problem is, I mentioned vitamin B12 as a particularly complex molecule, and then I said hydrogen was like easy or light stuff, but it's not. If you go into the hydrogen deeply through quantum chemical methods, physical methods, and if you do mathematics and so on, you can write books and equations and then a lot of theoretical stuff. So it's not an easy subject. So to understand hydrogen and to all of that properties which this gas can have in different modifications, in different formulations, under different circumstances, you wouldn't believe. It's unbelievable. And simply, let me put it this way. You know that gases are soluble in water, and you know that the oxygen is soluble in water, and this is why fishes and algae and all of those stuff live in the oceans and seas,
Makes
rivers.
Sense.
Yeah, on oxygen, which is dissolved in the water. Hydrogen, the same, is dissolved in the water. And there is a law which is called Henry law of gas solubilities in water, which says that certain gas, like hydrogen, can dissolve in water, in 1 liter of water, milligram per liter or whatever, millimole, whatever you want to use a unit. It's soluble to a certain level until it saturates the water. This is Henry law. And for the hydrogen to saturate the water at room temperature, normal atmospheric pressure, is 1.6 milligram per liter. This is approximately a little bit less than 1 millimolar solution. We call it this way because it's one of thousands of molecular mass of the hydrogen dissolved in 1 liter of water.
So I'll convert that to English. So
Okay.
That's always my challenge. It's like, how can you tell this to a crowd of pedestrians in Las Vegas or someplace else? But what the measure that we have, the capability we have with the molecular hydrogen testing device is the maximum you can have in the world is 1.6. So if you had anything that was nearing even half that, that would be a miracle to produce in just something that you could ingest. So that's what we're going to do here. So
it's some sort like a speed, you know, like a speed limit or something. So it's a limit. Now, what is the beauty with our product? We can go beyond that, which is, in first instance you say, oh, you cannot violate certain laws. But yes, you can if you have a particular form of the matter which can violate the Henry law. And our nanobubbles, negatively charged of hydrogen, really can violate. It can go beyond 1.6 milligram per liter, can give 2 or 2.8. Sometimes, of course, if you put a lot of powder, you will get high numbers, which is a beautiful result and opens up a new world. And because once you go beyond certain limits, which are physical limits, you have another world.
So you're breaking the speed limit without a ticket.
Exactly. Exactly.
Very good. Okay. Well, I tell you what, let's go ahead with some of the testing here. Again, everybody, we're going to be testing 3 things. pH, and we have a pH meter. We're going to test NORP, which is a very, very potent antioxidant test. Normal water.
It
should be negative. And I've tested water products that claim to be healthy.
Always positive.
It's always positive. And so if you're drinking certain water products and there's a positive NORP, that's not what we're really after. So what we're looking for here is a negative NORP, a alkaline situation with the water, and then of course the measure of molecular hydrogen, which truly in my life and as long as I've known Dusan and in our experience with 7.2, this is the first time that anybody has seen this. So this was kind of exciting for me.
Okay.
So shall we?
Should
we start with
pH, for example?
Let's do that here. And
you can stir.
Yeah, we'll stir that
up. I will put on.
My scientific advisor.
I don't know whether I will try to show this, which is.
Well, what I'm going to do is, as these reach peak, I'm going to use my handheld camera and take a photo so we can show that later.
Okay. So now, at this moment, after 5 minutes of putting the powder into the water, and this is the least amount of powder, we can read here 7.25.
I thought that was 7.2 for the longest time. Surely.
Yeah, I think
it stayed there for the longest time. I saw it.
Now it's going up, it's 7.3 and so on, because this powder works, I mean, in a very dynamic way, and it will work next 10 minutes. But if you take your drink within 10 minutes, it will develop this. But in stomach, it will go back to acid because you have stomach acid, but it will neutralize the excess of acid. But it's interesting to see in the beaker, before you drink it, it's already 7.5.
It's still climbing. So, and for those of you used to the colorations here, we're already down at this very alkaline spectrum if we were doing the color test. So, and these machines are very, very accurate and very graphic. So,
and you see the clearness now. The solution of this smallest dose, it's almost clear. It's very close to be like a clear water, like this. You see.
And that's compliments to the chef, Dusan. Your very specific breakdown of the ingredients. All right, now we have
testing. A little bit more powder. So
and this would be the normal dose. So this was 2 scoops of the powder.
This would be the normal dose. This is really half of the dose. This is the normal dose. This is 1.5, you see. And all the time the pH won't be too much.
That's leaping off the chart.
But you see, more powder you add, you have a higher pH because you have a higher alkalinity, or you have the higher buffering capacity. So now we have something like, if Bill records this, it's 8.45. This is.
Ladies and gentlemen, just for everybody, that is off the chart. All right.
It's off
That
the
is
chart.
literally
So
off the
it's
charts.
pretty much alkaline. So it's 8.5 here.
Dropping
It's
down,
less.
but still
It's
above 8.
it's around 8, 797, 796. So more powder, more alkalinity, and the less powder, less alkalinity, but still
So sometimes more is
reasonably
better.
okay. It's still over 7.8.
Yeah, that's fantastic.
Fine. So
Very
this
good.
is the most alkaline, medium alkaline, and this is the least alkaline.
All right.
Okay, this is the regarding pH. Let's have a look a little bit
And now we
about
can go
ORP,
into the,
oxidation reduction potential.
and a lot of people ask me about ORAC and NORP and the difference.
Oh.
And let me tell you, there is no comparison, but ORAC is out there as an antioxidant test, largely in colored things, colorations. And so if you took red wine versus water, it would have a higher value. But in an antioxidant cellular effect, NORP is truly, correct me if I'm wrong, truly the better test.
Oh, absolutely.
Good. All right, well, shall
Okay,
we?
let's, yeah,
I feel
sure.
like I'm diving in.
Yeah, sure. Let's-
All right. And with water, again, it's always very positive, and here it's already going into the negatives.
Yeah. So the water, distilled water, usually it's over plus 200, you see.
Mhm.
And now this half a dose is producing something already. This is the electrode was
I think
activated. You think so?
I might just change this real quick here. I have a, let's see here.
Because sometimes with these instruments you need to a little bit sand
Constant.
the electrode to get rid of some oxides.
You know, I can do that right now.
Yeah, maybe we should
Here we go.
tell
Just a little cleanliness
people,
here.
yeah, that we need to do a little bit of
Here we go.
sanding the electrode.
Watch this. A little better. Oh, there you go.
Yeah.
Now it's going into the minus 200s.